Continue with Vignette 3. This is part B. Again, problem 13, section 2.1, page 58. Part B asks to see whether the map W equals Z squared maps XY equals 1. That's the hyperbola that looks like that to a straight line. Well, this is easy to parameterize. We can even use x as a parameter if we like. So that's y is equal to 1 over x. So that's equivalent to z is equal to x plus I over x. And now we're actually using x as our parameter. And if we like, this gives the sense of direction this way. As x is increasing in this direction. And quite clearly we have a problem when x equals 0, but that's okay. Let's see what happens. So w equals z squared is x plus I over x times x plus I over x, which is x squared minus 1 over x squared. So x times x minus I, plus I over x times I over x gives us minus 1 over x squared. And then we have x times I over x, which is I, plus I over x times x, which is I. So that's I times 2. So the graph of that, no matter what x is, has to lie on the line where the imaginary part, so this says u equals x squared minus 1 over x squared, and this says v is equal to 2, so it's always going to lie on the line v equals 2. And the question is, how much of the line gets covered? What does the real part do? What does u do? Okay, well, we have to figure out what the range of x squared minus 1 over x squared is. One way to do that is just to think about what happens as x goes to 0. As x goes to 0, as we go backwards along here, this goes off to minus infinity. And as x goes off to positive infinity here, this part goes off to positive infinity. So we know we at least match parts out at negative infinity and parts out at positive infinity. The question is, do we actually cover the whole line? And is there any place in here that jumps over or does something crazy like that? And that can't happen. If we draw the graph of u equals x squared minus 1 over x squared for positive x, we just said that when x goes to 0, this u goes off to minus infinity, and when x goes to positive infinity, u goes off to positive infinity, sort of like the curve x squared. And the question is, how does it join up in there? Well, maybe it has little bumps. So let's take du by dx and see. Du by dx is going to be 2x, and this is x to the power minus 2. So it's minus x to the power minus 2. Derivative of that is plus 2x to the power minus 3. Pardon me. So that's equal to 2x times 1 plus 1 over x to the power 4, if you like, and which is always bigger than 0. It's 0 when x equals 0, but that blows up here. So it's always bigger than 0 for x bigger than 0. So the slope is always positive, so this thing goes up, and it crosses the axis, and it goes on like that. Where does it cross the axis? It crosses the axis when x equals 1. So exactly when it's there, we have u being 1 minus 1, which is 0. So that's fine. So this line goes from minus infinity to plus infinity as x goes to 0 to plus infinity. So on this one, the direction is this way. On this one, we're going from minus infinity to 0. So that means this is plus infinity, u is plus infinity. And as we get to 0, this goes to minus infinity. So in fact, this one covers the line in the opposite direction. So let me just indicate that that's that one. And it goes the other way for the other axis.